All right, so what I want to show you is how to diagram once we have those measurements. And so we'll start with the one that was off in the distance. For my example, it was a tree. And basically what I did is I set down 2 pointing devices to point at the tree from different locations. So when I diagram it, what I'm going to do is I'm going to kind of like actually do a little bit of a dashed line to say this is like my laser shooting at it, or it's my line of sight from my 2 objects. Okay. And then for good measure, I'll draw in a little round pointing device there at the end. So I'm actually trying to not just draw a triangle, I'm trying to diagram the actual setup that I was using. And in the video, this spot right here, where I was trying to measure from, this spot was like a pole, and I wanted to know the distance from the pole to the tree. Okay, and then I took a tape measure and I draped it across there. All right. And what's interesting, and I just realized this just thinking about it right now, is I should have had my tape measure actually be at this pole. I think I had it drape across over here. But if I wanted to know the distance to the pole, then my tape measure would drape across right to where the pole was, and I made it drape a little bit, whatever. I could always measure what that distance was and add it to it. That's something I could do. And the difference is only a matter of inches, and this thing's really far away. So it's good enough for our approximation purposes. Okay, and if my memory serves me correctly, it was 122 inches and 5/8. And then what I recorded for these measurements here was that I recorded, I believe I said 72 degrees and 103. Okay. And so that's the kind of diagram I want to see. I want to see you actually draw like the object that you give a little sketch of it. And then we've got these 2 lines of sight, and you can have like these dashed lines. Use a ruler to make it straight. And they're coming from these pointing devices, and you measured across the distance between them, and then you measured an angle that was made from your tape measures, and then you wrote them down. Now, this drawing does not need to be perfectly to scale. You can actually look right here, this angle as drawn is actually close to a right angle, and I put 72 degrees. And this angle as drawn is an acute angle. I mean, that's less than 90 degrees, but what I recorded when I measured it was 103. So I'm not asking you to draw perfectly, okay? Like if I were to draw it more accurately, it'd probably be more like a line like this, and it'd probably actually be narrower and all that kind of stuff. I'm not asking you to have your drawings be perfect. They just need to be representative, that you pointed one something, you pointed something else, you measured the distance, and you got those angles. We'll let the calculations determine what we want to know. Okay. So same thing here. I took a tape measure along the ground, and I came out 22 feet. Let me try to draw that here. Okay, so I got 22 feet, and then I took a pointing device and I pointed it from that ground at 22 feet all the way up to the top of idea. So let's go ahead and use the dashed line to indicate it was a line of sight, and then down here at the bottom I'll put my little pointing device. Okay. All right. Now, in my scenario, what I ended up getting is I had this little, and let me make my pointing device longer in the drawing to make this a little clearer. So I had this device pointing up to the top of idea, and then I had a string hanging down on a weight, and the angle that I measured inside of there was 28 degrees. So it's going to be tough to write 28 degrees right, and actually this is behind my head here. So it's going to be tough for me to write 28 degrees right in there. okay, because that's what I measured. So, but this is vertical, and so is this, which means they're parallel, which means that this angle and this angle up here are the same angle. Okay, and then I can write in here that I got a 90 degree because the ground is level and the building's going straight up. Okay, so if it's too small to write in here, if you're using that, if I had measured from the ground, I would have gotten a 62 degree angle, so I would have written it right there. And so, yeah, so there you go. And then what you do from that point, before we can go sort of set things up and do equations, the last step is to note that you have two angles, 103, 72. If I was doing this one from the bottom, I'd have the bottom angle and the 90 degree angle. Since I was doing it from the top, I had 28 and 90. You have two angles. Remember that you can figure out what the third angle is because all angles in a triangle add up to 180. You're just going to take 180 and you're going to subtract your other angles. So 180 minus 103 minus 72. And you can pull out a calculator, or if you can do this in your head, great. But you can just pull out a calculator, you get 5 degrees for that top angle there. If I had done this here with the 62 and the 90, if I did 180 minus 62 minus 90, I would have gotten 28. Or if I'd done it the other way, where I did 180 minus 28 minus 90, I would have got 62. So this one's all done. I have my 3 angles here. I have my 3 angles there. Once I have my 3 angles written down, I've got my clear diagrams, and then I have the one distance that I measured marked down on my diagram. Now I have the information that I am going to need to calculate the height or the distance, and we'll set up those equations in just a moment.